Section 2.1 is on frequency distributions for organizing and summarizing data. So a frequency distribution, which we could also refer to as a frequency table, is when data is partitioned over several categories or classes, listing the categories with the frequency or the number of data values of each. These can be either numerical or categorical. The lower class limit is the smallest number that belongs to each class. The upper class limit is the largest number that belongs to each class. The class boundaries, these are the numbers used to separate the classes, no gaps, meaning based upon these two. Class midpoints, those are the values in the middle of the classes, so you average the upper and lower limits. And the class width is the difference between two consecutive lower class limits. And to make a frequency distribution, you'd first select the number of classes. And typically, in order to accurately graph a data set and discover its shape, we would tend to use a number of classes somewhere between 5 and 20. Which that may or may not be affected by rounding once we get to the actual data. But typically between 5 and 20 is typically good to, again, note the shape. You would first calculate the class width and round up. So that's maximum value minus the minimum value divided by the number of classes, and again round up with this calculation. You would then choose the lower class limit, either the smallest value or some number close to it. Then use the lower class limit and the class width to write out each class. You would then list the lower and upper class limits in a vertical column, and then take each individual data value as a tally in each class and note their total frequency. So for example, using these IQ scores for the low lead group to construct a frequency distribution with 5 classes. So this top data set here. This would be, for us to space it out, an IQ score of between 50 to 69, there's 2 of those. Between 70 and 89, that would be 33. Between 90 and 109, that's 35. Between 110 and 129 is 7. And between 130 and 149 is 1. And I believe if you go through this data set, the largest value on there is, let's see, 141. Let's see if there's any other ones in there. Nope, 141 it is, it looks like. Yes, okay. So 141 minus the smallest value on there was 50. And we want 5 classes. And if we do this out, we should get 91 over 5. And if you do this division here out, you would get a value of, let's see, this would be a 1, 18, and 18.2. So this would round to 19 when you would run that up. This is why these have a class width here of 19. So there's 19 between 50 and 69, between 70 and 89, between 90 and 109, 110 and 129, and 130 and 149. For the relative frequency distribution, this is the percentage frequency distribution each class frequency is replaced with a relative frequency, or relative proportion, or relative percentage. The relative frequency for each class takes the frequency for a class divided by the sum of all frequencies. Likewise, the percentage for a class takes that same frequency for a class divided by sum of all frequencies times 100%. And the sum of the percentages in a relative frequency distribution must be very close to 100%. But due to rounding, it could be, slightly above or below. But again, that's just based upon the way it's rounded if that was the case. So for example, that data set that we were just looking at a few moments ago, involving the low lead group IQ scores, we can write out each of those frequencies, the largest of which was that 90 to 109 IQ score. Now, a cumulative frequency distribution. This is the frequency for each class is the sum of the frequencies for that class and all previous classes, which is why the class limits are replaced by a less than terminology to describe this new range of values. So, for example 3 here, if we wanted a cumulative frequency distribution for the IQ scores of that low lead level group, we would have, as we have on here, less than 70, less than 90, less than 110, 130, or 150, and each of these then would be the sum of the ones below it plus the one that was in that specific bin, which is why this cumulative frequency looks as such. To use the frequency distribution to understand data, this would be, to understand the distribution of the data, this would be the center, spread, and overall shape. Okay, those are those 3 properties that we always want. And it uses the normal distribution characteristics. And what that means then is the frequencies start low, then increase to 1 or 2 high frequencies, and then decrease back to a low frequency. The distribution is approximately symmetric. The frequencies preceding the maximum frequency should be roughly a mirror image of those that follow the maximum frequency. And my picture down here is slightly cut off. Let me just give a very quick rundown of what this does. Just recopying over all these classes. And 130 to 149. Head on 1. 10. 56. 10 and 1. Alright. So, this begins low and ends low. Right? The second from the top and the second from the bottom, they're both increasing. And then this 56 is the highest. And a normal distribution is typically, and I'll draw it down over here just so it's not completely out of the way, looks something that's kind of like a bell. So it's one high point, which would be that 56 according to this data. The frequencies of last digits sometimes reveal how the data were collected or measured. The presence of gaps can suggest that the data are from 2 or more different populations, although the converse of that is not true. If you have data from different proportions, they might not necessarily have gaps. But if we combine 2 or more relative frequency distributions in one table, we can make comparisons of the data much easier. Unfortunately, if we were to do these frequency distributions in SAS, they are not going to be combined. They would make 2 totally different tables. So do bear that in mind. Likewise, if we looked at the low level and the low lead level and the high lead level groups and look at the IQ scores. This will be the frequency distribution for the low lead level group. But notice the high lead level group, in order to fit it with this one, notice we only have 2 categories here. And of course, doing that is not going to really tell us too much about its shape. So, when combining them in the same way like this, you have to balance that with the idea of knowing the shape versus those comparisons. Right? Due to, again, the fact that you can't really tell a shape from the high lead level group just based on this frequency distribution. We'd have to have a much more expanded one. Thank you.